All right, so binomial exists if there are exactly two possible outcomes. Bi implies two, right? And there's got to be a fixed number of trials. You'll understand what that means in a minute. Just like it's a set number of times you're going to do something. And they're independent, like they can't depend on each other. They have to be like a coin flip where they don't depend on each other. But there's a lot of those situations. Here is a tree diagram. And I don't want you to have to do the whole thing here, so I just want you to think about this tree diagram for a minute. If I had a 65 chance of hitting the shot, that means what probability do I have of missing the shot? A 35. And then if I were to go all the way up this route, it'd be 65, 65, 65, and I'd multiply them all together. All right, I'm going to give different rows different jobs to multiply. Would you please grab your graphing calculators? And I will get these numbers from you. We'll kind of share it so we don't have to each make this giant tree. We'll share the responsibility. In this row right here, you guys are going to start by multiplying 0.65 to the third. That'll be easy. All right, this row right here, I want you guys to do the one where it's 0.65 and 0.65 and then a 0.35. This one right here. This row right here, I want you guys to do the one where we have 2.35s and 1.65. All right, and then guess what? There's for all those three rows, there's really only one thing left. 0.35, 0.35, and 0.35. Because they're just different rearrangements of the same thing. All right, so this first row, what did you get for that first one? Say that one more time, a smidge slower. 2746. 746 would round to 5, so I'm going to go with 0.275. All right, next one up, this row right here where you got the 265s and 135, what'd you get? 0.14787, so I'm going to go 148. All right. And then how about this one? Just think about this for a second. 0.65, 0.35, and 0.65. Isn't that the exact same thing? This, and this. As this one would be. This, and this. It's just in a different order. So it's still going to be 0.148, isn't it? All right. Now that's part of the pattern that you need to understand. You need to see that it's the same thing. All right. And how about the row that did the 2.35s and 1.65? What did you get for that? 0.796 would be, I would actually round to 0.080. All right. And now all the numbers have already been computed. I don't need to do them again. This is a miss and 2 hits. A miss and 2 hits is the same as 2 hits and a miss. So it's this 0.148 number again. And now, let's see, 2 misses and a hit is the same as this one. So this one and this one are the same thing. So I can go 0.080, be 0 in there, 0.080. And then, let's see, 2 misses and a hit, it's the same exact thing as this, 0.080. And then the last thing is, okay, you 3 rows, what did you get? Somebody. 0.428 would round to 0.43. Okay, so now let me make sure you understand. You can see how that's kind of a pain in the butt to have to make that big of a chart. And that's only 3 shots. Can you imagine if I gave you a problem on the test, which I am going to give you? It's going to have like 8 shots. Can you imagine making 3 for that? It'd be a mess. It'd be a nightmare. It'd be hard to keep track of all the numbers. And so there's a better way. That's what I'm going to show you right now. You won't have to make a tree for it. There will be like 8 shots. All right, so here's how you do it. If I wanted to know this answer to exactly 2, what's the probability he will make exactly 2? That would be things like this. This is exactly 2 hits and 1 miss. This is exactly 2 hits and 1 miss. And this is exactly 2 hits and 1 miss. So I'm going to erase the arrows. Other ones there. Those 3 arrows, those are all the answers that I would want to add together. Or would you agree that it would be 0.148 times 3? Then there's a way to do that without the whole tree. All right, so this is the part where you need to pay attention really close. So there's a C in the front and two sets of parentheses. The two sets of parentheses are going to make total sense to you. There's 0.65s and there's 0.35s. And do you agree that if I hit exactly 2, that I have two 65s and therefore one 35? Does that make sense to you? All right. Now here's the thing. How many of them are there, though? That's what you need the tree for, is to see that there's 3 of them that are like that. But this C will answer it too. Think of it from this perspective. What if I just said he's going to shoot 3 shots and you want him to make 2? What do you think I'm going to put for this? 3C2. You got it. And take a wild guess what 3C2 comes out to. 3. Because there's 3 paths. 3C2 looks like this. 3 factorial over 3 minus 2 is 1 factorial, which doesn't really do anything. And then the extra one of these, which we have 2 factorial. That means the answer is 3. Because it's 3 times 2 times 1 on top, and the 2 times 1 on the bottom cancels that out. All right. Bottom line, if you didn't understand where this came from, this is how many paths the tree would have had, and this is the numbers you'd multiply on each path to get the 0.148. So the cool part is now, if you understood what I just said there, you could write one of these things for a situation that's got, it's unlimited, it doesn't matter. Let's make it a dozen. Okay, let's say that you're going to get 12 shots on goal in hockey over the next month. Okay, and let's say that you know your average, how many hockey players in here? Raise your hand if you're a hockey player. All right, then you guys should be the ones to answer this. If you were to say a number of shots on goal taken in a game compared to how many go in, what would you guess is the average? If you take a shot on goal, what's your percent chance of actually making a goal? Is there like 3 times as many shots as there is actually goals, or is it more like 4 times as many, or what? Just give me a gut feeling. Say that again. Okay, so it's about a 1 in 10 chance. So if you take just a random shot on goal, it's only like a 1 in 10 shot of making it. Okay. So then we're going to say there's a 10% make chance on shooting a shot in hockey. You just go skate down there and you take a shot, 1 in 10 chance it goes in. Of course, the coach doesn't want you to do that because he wants you to get in higher probability situations, right? He wants you to get the pucks where you're going to have a much better than 10% chance of it. But, all right, so then 10% make, what do you think that means? 90% chance of miss, right? And then if I'm going to take 12 shots over the course of the next month, if I'm going to take 12 shots, that means I'm going to put a 12 right here. Okay? Now, let's say, what would you expect to happen? If you took 12 shots, given that you make about 10% of them, how many would you expect to probably use? Maybe 1, maybe 2, right? What do you think the most likely numbers? That you'll make 0 of your shots, 1 or 2, something in that zone, right? 0, 1, or 2. All right. Well, then let's figure out the probability of hitting 1. So we're going to go with C1. That means I have 12 shots and I want to make 1. The make one is 1. How many of the miss ones are there? There's going to be 11 misses then. Would you please, right now on your calculator, type in 12C1. 0.1 to the 1, and 0.9 to the 11. Multiply it all together, and I want to get several people doing it because a lot of times people mess these up, and I want to not just take the first answer I get, I want to make sure it gets verified by some people. Anybody verify 0.376? All right, good. 0.3765 would actually be a 377. So that means that there's about a 40% chance you're going to make one of your shots. If you had to guess, what's the next most likely scenario? That you make 0 shots. All right, let's go for 0. 12, C, what now? 0. where I make 0.10. How many of those do I have? 0 makes. And anything to the 0 power, can't you just make that 1? And how about this? What do you think 12C0 is? You'd think it was 0, but then the answer would be 0 because it would be 0 times everything. It's 1. Because this is defined as anything to the 0 power would be 1. This will be 1. So that's 1 times how many misses? 12. There's a pretty high chance of that. Not super high, but it's one of our top options. 0.28. Anybody verify 0.28? Thank you. All right. So there's a 28% chance you're not going to make any of them. There's a 37.7% chance you're going to make one of them. Let's do our one last one. I'm going to move these down so that I keep them in kind of a logical order. And let's figure out that last one, which is 12C2. Everybody do it on your own. See if you get the same answer as the kid sitting next to you. Give it a shot. When you're done, turn your calculator, show it to your friends, see if they got the same thing as you. Anybody sitting near you can be your friend right now. For this little moment, they will be. So hopefully you did 2 for this and 10 for that. Show anybody yet? Show somebody nearby. See if they got the same as you do. All right, I'm back from the pause there. What did you get for that chance of making 2? Yes, sir. 230. All right, so there's about 23% chance of that. The top 3 usually hold about 80 to 90% chance that the ones that are around there are the ones that are going to happen. So if we went all the way to the most ludicrous situation, which is you making 12 out of 12 shots, which again, given that this doesn't happen that way in hockey, that would probably be like a 0.00005 chance of that happening. But these added up are usually like 80 or 90. Let's see what it really is. 37, 40, 50, 65, 70, 85, yeah, about 88% chance or so, maybe 89%. That'll be one of those 3. Did you get what we just did there? It's really, really powerful. I'll give you another one, and I think you're already good at it enough that you'll be able to just answer it really, really easy. Okay, let's say that a kid is a 90% free throw shooter, and he's got 3 pressure free throws at the end of a game. What's the probability he makes 2 out of 3? He's a 90% free throw shooter. What's the probability he's going to make 2 out of the 3 shots? I didn't say at least 2 out of the 3. That'd be different. Got an answer or a question? I think that's an answer, isn't it? Okay, then just hold that thought a second. I want to make sure I got everybody through typing because I see a lot of people type stuff on the calculator. All right, there's always a C. There's always 2 sets of parentheses. This is always the thing you want. This is always the thing you don't want. Then, this is always the bigger number, the total number of tries, and this is the smaller number. And then this number is always right here. And then these 2 numbers together always have to add up to that number. So there you go. Raise your hand if you set it up right, at least. Okay, good. And then when you actually typed it in, what did you get? Front row in the orange. Or, wait, 243. Can anybody verify that? Excellent. All right, so what that means is there's only about a 24% chance that the person will make 2 out of 3. What do you think is more likely than that? To make all of them. Let's check 3 out of 3. Just think for a second though. Do you really need to do 3C3? What's it equal to? 1. So I don't need to do that. And then if we make all 3 of them, it's just 0.90 to the 3, right? And then this other thing, you don't really have to do it because it's to the 0 power, and anything to the 0 power is equal to 1. The final answer is 0.9 to the 3. What's your final answer on that? 729? So it's pretty likely the kid's going to make all 3 of them if he's a 90% free throw shooter. It's about a 72.9% chance of it. If you put these together, 97% chance that it'll be one of those. Now, does this factor in the real-world pressure that the kid could experience at the free throw line? Do you think that might make it harder for him to make 2 out of 2 or 3 out of 3? Or 2 out of 3 or 3 out of 3? In the real world, math doesn't take that into account. So you can make it do that, but it makes it much more complicated. Then you have to know, is this the kind of guy who folds under pressure? Or is this the kind of guy who's used to pressure and actually rises to pressure? Kind of interesting statistic. Some of the greatest basketball players actually shoot better when they're under pressure than when they're not. They actually, like, it makes them better. And like Michael Jordan was a famous one for many years, and he would, when there was a lot of pressure, he wanted the ball. He wanted to be the guy who would take that shot because he just had this confidence that I can do it. He'd done it enough times. So, anyway. All right, so this doesn't take into account some of those sort of ethereal sort of things that can affect the real world. All right, what you need to know, you already have learned. You have learned the Binomial Theorem, so your homework for today is going to be pretty easy with one exception. If they ask you, what's the probability he makes at least 1 out of the 2 shots? Well, then you got to do 1, and you got to do 2. And then what do you do to them? Add them. Because they're not choices. If they were choices, you'd multiply them. But they're 2 separate probabilities. And if I say at least, I mean this or this is okay. Okay, so if I had 5 shots, and if I said I want you to make at least 4 of them, then you'd add up 4 and 5. Okay. Here's the other weird one. 5 shots. What's probably to make at least 1? Well, then that's 1 and 2 and 3 and 4 and 5. So what's a smarter way than adding all of those up? Yes, sir? You got it. They would all add up to 100%, right? So if you want to find the probability of at least 1, what they're really saying is the probability of not 0. So you find the probability of 0, you take it away from 1. All right, so either that, or if you really don't like that way, go ahead. Add up 1 and 2 and 3 and 4 and 5, and it'll work. It's just way, way slower than taking 1 minus the other, the one that you didn't. Okay. So let's do 1 like that. So let's say, given this scenario, you got a 85% free throw shooter, and let's say that they get 8 shots. What's the probability that they'll make at least 1? If you want to do it the slow way, it's probably going to take you 15 minutes. The probability of at least 1 would be the same as just not 0. So what's the probability on the 0 thing? You do this. And you say 8, choose 0. And then there's an 85% chance of making, and then there's miss is 15, make is Let me think. 0, 0. This has to be the same. And then there must be 8 misses to make that work. And then you get this answer, and it's really small, and then what do you do to it? Subtract it from 1. That'll give you all the other ones. Okay, so this one comes out to 0.00. What did it come out to? What? 4 zeros? 6 zeros? And then what? 2, 6, so I'll round that to a 3. And you take 1 minus that, so obviously there's like a 99.999% chance that he's going to make at least 1. And that makes sense. So you're an 85% free throw shooter and you got 8 shots. You're going to make at least 1. Very, 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 very high probability that you're going to make at least 1. And again, this doesn't count in pressure if somehow the person's being freaked out. And there's a reason that they make all those crazy faces and noises and things while people are shooting the free throws because they're trying to throw them off. And that works. To make it harder. All right, I think I just should summarize this and say 1 minus that would be your final answer. So just put in zeros. There you go.